Hi, I'm Wenzhe from Stony Brook University. Next, I'll share research with you. BackSwipe, back-of-device word gesture interaction on smartphones. We create BackSwipe, an input technique that allows users to input word gesture anywhere at the back of the device for command and text input. To enter a word, the user holds a phone with one hand and uses the index finger of the same hand to draw a word gesture on an imaginary invisible keyboard, which could be anywhere on the back of the phone. For example, to enter stop command, the user draws a gesture on the back of the phone, tracing through STOP. In the following parts, I'll share our work with you. First, we carry out a study to understand how users perform word gesture input on the back of the smartphone. We instructed the participants to hold the phone naturally, imagining an invisible keyboard on the back of the phone, which could correctly decode their input. The study is a transcription task. The participants were instructed to draw a word gesture on the back of the device to enter the phrase. We analyze all the gestures and get a new imaginary keyboard layout using dynamic time warping. In the example, we use DTW to match 3 letter points in the template to the corresponding ones in the gesture. Then we can get the letter positions in the gesture. In this way, we get a new imaginary keyboard looks like this. The picture is the average key distributions for all participants. As we can see in the figure, the shape of the imaginary keyboard is close to a square rather than a rectangle. During the study, the user tend to adjust their hands posture when they feel tired or uncomfortable, so the imaginary keyboard should not be assigned to a fixed position. Based on the findings, we designed a decoder for the back screen word gesture. In gesture typing, the decoder needs to calculate the probability of the word W given an input gesture. It is the SW in the formula. To get SW, the basic principle is to combine the spatial probability CW and the language probability LW. To get CW, we apply the basic algorithm in SIGCHI. It was firstly proposed by Ramakrishnan and Zheer in 2004. And simply speaking, this method compares the location and the shape of the gesture with those of the words in the vocabulary. For language probability, we implement bigram language model for the first two words, since there is little language context. And the GPT language model was used for the following words. According to what we learned from the first study, we designed an interacting updating algorithm to update the center of the imaginary soft keyboard after entering each word. Simply speaking, after user confirms the input, we'll change the keyboard center to the newly estimated position. The figure is the architecture of BackSwipe decoder. After user input a gesture trace, the scoring component will combine the spatial and the language probability and output in best word. And the user will select from those words, and the keyboard position will be updated according to the new gesture. Here's how it works. During the text entry, the system will display 4 suggestions. The user needs to double-click the back screen to confirm, or she can swipe at the back of the screen in 4 directions to select the corresponding suggestion. Next, we carry out 2 experiments to evaluate BackSwipe for command input and text entry. The result shows that in command input, the average command input time is 5.32, and the average command input error rate was 7.5%. And for the text entry result, the average input speed was 9.58 words per minute, and the average word error rate was around 11%. Here are some demos. We can draw photo to open photo. And we can draw a torch to open torch. Thank you.